Hello everyone. So, ngayong araw ang di-discuss natin ay transmission at saka reflection of unbound states. Okay? So, pag sinabing unbound states, ang ibig sabihin nito ay mga states na hindi bound as a result of for example, potential well, or a square potential or infinite barrier potential. Okay? Meron pa rin silang potential na nararamdaman. Okay, but yung potential na yun ay hindi nagko-cause sa kanila na tawag dito matrap within a finite region in space. Okay, classically, before that, ang titignan nating tawag dito potential dito is a potential step. Okay, so a potential step looks basically like this. Okay, so you have two regions, region 1 at region 2, na yung isang region ay may potential na V1 at yung isang region ay may potential na V2. Okay? Classically, ang ina-expect natin dito ay yung particle ay hindi mag-pass through pag yung energy niya ay mas mababa kaysa dun sa potential ng particle. On the other hand, pag yung energy niya ay mas mataas kaysa yung potential nung wall, okay, then magbe-break through siya dun sa wall at pwede siya mag-pass through. So in quantum physics, iba yung situation. Okay, yung transmission through a potential barrier or reflection from a potential barrier, okay, can happen, okay, simultaneously. Okay, so meron lang probability na ma-reflect yung particle or ma-transmit yung particle. Depende dun sa, in this case, relative difference nung dalawang potential. Okay, at yun yung titignan natin ngayong araw. So we'll start discussing a potential step, okay, in one dimension. So in one dimension, we have this potential step tulad ng pag-describe natin kanina. You have two regions. Sa region 1 may potential na V1, sa region 2 may potential na V2. Itong V1 na ito, since relative, ang importante naman dito is yung relative potentials, can actually set this to 0, and then V2 will just be some potential relative to the 0 value. Okay. So for now, we'll just leave it at that para mag-generalize natin yung idea. Okay. Yung y-axis dito ay yung energy at yung x-axis dito ay yung position. So the higher yung value, yung V, ibig sabihin mas mataas yung kanyang potential. So in this case, V2 is greater than V1. Okay. So V2 is greater than V1. Now, nagkakaroon ka ng potential step at position x equals x naught. Okay, and we will set x naught to be equal to 0. Okay, yung mga letters na nakikita niyo dyan, A, B, C, at saka D, correspond to the amplitude of the wave function. Okay, so yung wave function that is propagating towards the barrier. Okay, so yung wave function is propagating towards the barrier has an amplitude A. Okay, at yung wave function that is propagating away from the barrier in region 1 has an amplitude B. On the other hand, yung wave function na propagate away from the barrier sa region 2, okay, ay may amplitude na C, at yung wave function that is propagating towards the barrier sa region 2 ay mayroong amplitude na D. Okay, as what we did before, we always start with Schrodinger's equation. Okay, so in general, okay, we can write Schrodinger's equation as negative h bar squared over 2m d dx squared, okay, plus v of x, okay, times psi of x equal to e psi of x. Okay, and ang solution dito, okay, is for region 1, we have a wave function which is given by psi1 of x, a exponential I k1x plus b exponential negative I k1x. Okay, so yung tulad ng sinabi natin, yung a is a wave function, is the amplitude of the wave function is propagating towards the right in region 1. So yung amplitude na yun, or yung wave function is described by this exponential function. Okay, yung b is the amplitude of the wave function is propagating towards the left, away from the potential barrier in region 2. So ito yung makikita natin. So yung negative sign dito actually indicates yung negative sign dyan, tsaka yung positive sign dyan, indicates kung anong direction sila napopropagate. So positive meaning going to the right, and negative going to the left. In the same way, sa region 2, yung wave function is given by c times exponential I k2x plus d exponential negative I k2x. Kung saan yung wave function na exponential positive I k2x is the wave function that is propagating towards the right, and yung wave function that is described by exponential negative I k2x is the wave function that is propagating towards the left. Okay. Okay. So ano yung K dito, by the way? So ang K1 o ang Kj, shall we say, okay, is equal to 2 times yung mass J nung particle, okay, E minus V sub J, okay, yung potential at the Jth region, okay, divided by H bar, and then ito na sa ibabaw yung naka-square root, na kung saan yung J corresponds to the region. So if J is equal to 1, then we're referring to region 1, and if J is equal to 2, then we're referring to region 2. Yung energy dito, okay, corresponds dun sa energy ng particle. So if we have a particle with energy, with some value of energy na ganito, okay, ano mangyayari sa kanya, and then if we change yung energy, ano mangyayari sa kanya, and so on and so forth. So we're actually going to scan overall energies at titignan natin kung ano yung magiging kung ano yung transmission at saka reflection probabilities, essentially. Okay. Now, pag yung energy nito ay less than V2, okay, so ibig sabihin ito yung ano, no? Ito yung V2, at pag yung energy is less than V2, then we expect, okay, from this equation, we expect that this wave number, okay, is imaginary. Okay. If E is less than V2. Okay. So ngayon pwede na tayong mag-calculate ng tawag dito, probabilities, okay, ng scattering. We call this scattering, so reflection of the barrier at saka transmission through the barrier. So scattering probability of a particle moving from region 1 to region 2. Okay, okay, I would also like to mention yung mass dito, okay, also has a subscript, M sub J. Okay, yung J also corresponds to the region. So what does it mean na meron kang mass sa bawat region? It means na tawag dito, yung mass na yan is affected by the potential. So ang tawag natin dyan is an effective mass. Okay, nakita niyo yun sa sa mga anong tawag dito, sa mga calculations sa previous na meeting, di ba? Ang ginamit natin actually na effective mass is 0.07 times m naught, where m naught is the mass of the electron. So we're only considering like 7% of the mass of the electron. Okay. And yung effective mass is, well, you can think of the effective mass as yung mass ng isang particle as a result of kung ano yung potential na naramdaman niya. Like, halimbawa, kung nag-swim kayo sa water, okay, dahil mas mabagal kayong tumakbo, okay, halimbawa, tumatakbo kayo sa ilalim ng tubig, okay, dahil mas mabagal kayong tumakbo sa ilalim ng tubig, yung effective mass niyo is actually larger. Well, it feels like na yung mass niyo is actually larger than yung mass nyo pag nasa ibabaw kayo ng tubig, pag nasa hangin kayo. So that's one way to think of kung ano yung effective mass. So it's a result of it's an effect of the potential. The effective mass will be discussed in better detail pagdating sa solid state. Pagdating sa solid state physics. Ang concern natin dito is how to treat yung scattering events nung particle dependent dun sa kanyang energy. So we begin with the case na kung saan in both regions yung M1 at saka yung M1 ay equal sa M2. Okay, so we know na yung boundary conditions, okay? So the boundary conditions dictate that the wave function of the wave function in region 1 at x naught must be equal to the wave function in region 2 at x equals x naught. Okay, similarly, yung derivative ng wave function na yan evaluated at x equals x naught must also be equal to yung wave function na yan in region 2 evaluated at x equals x naught. Okay, now yung psi 1 is a exponential I k1x plus b exponential negative I k1x. Dapat equal siya. So x naught na yan. So dapat equal siya sa c exponential I k2 x naught plus d exponential negative I k2 x naught. Okay, yes. So, okay. Yung derivative naman ito. Okay. Ano ang derivative nito? So if you take the derivative of psi 1, we have I k1. Okay, so I k1 muna and then a exponential I k1 and then evaluated at x equals x naught minus negative I k1b exponential negative I k1 evaluated at x equals x naught. Then I k2 c exponential I positive I k2 x naught minus I k2 d exponential negative I k2 x naught. Okay, and then sinabi natin na x equals x naught is equal to 0. So this actually reduces to the a plus b is equal to c plus d. And then a minus b is equal to, lahat ng imaginary mag-ano, no? And then k2 over k1 times c minus d. Okay. So, dinivide ko na everything by I. So, ginawa ko dito is dinivide ko everything by I k1. Okay. Kaya nagkaroon ng k2 over k1. Okay. So, let's assume that the particle is incident from the left. Okay. Assume that the particle is incident from the left. Okay, ang ibig sabihin niyan, okay, ang implication niyan is that yung probability that the particle is tawag dito, approaching barrier ay equals 1. Okay, so ibig sabihin A is equal to 1. Furthermore, if we take a look in this region, in this tawag dito, potential plot, okay, wala tayong ina-expect na particle na manggagaling from na magpo-propagate from infinity, from positive infinity papunta dito sa barrier. So, ang gagawin natin is we set d equals 0. Okay? Because we don't expect a particle, okay, from infinity, okay, propagating towards the barrier. Okay. So, ang matitira dito, so this becomes 1 plus b equals c, and this becomes 1 plus b equals 1 minus b, sorry. Equals k2 over k1 times c. Okay, so if we add these together, okay, pag in-add natin yung dalawa na yan, then we have 2 is equal to 1 plus k2 over k1 times c, or c is equal to 2 over 1 plus k2 over k1. Okay, and if we plug in c here, okay, then we have c minus, b is equal to c minus 1. So b is equal to c minus 1. Then we have 2 over 1 plus k2 over k1 minus 1, or b is equal to 1 minus k2 over k1 over 1 plus k2 over k1. Okay, so yan yung amplitude na dito. Okay, if we talk about probabilities, syempre kukunin natin yung modulus squared niyan. So we have for b squared, okay, magiging equal lang yan sa 1 minus k2 over k1 squared, and then 1 plus k2 over k1 squared. And for c squared, we have 4 over 1 plus k2 over k1 squared. Okay, we can also relate this to tawag dito, velocities. Okay, so let's say na yung momentum is equal to mv, and alam din natin na equal siya sa h bar k. So yung vi is equal to h bar over ki over m lang muna in this case. So this gives us v1 minus v2, okay, divided by v2 plus v1, okay, or v1 plus v2. Okay, wait. Okay, and ito naman will give us 4 over 1 plus v2 over v1 squared. Okay, and since v2 is greater than v1, it's a graph, v2 is greater than v1, then from yung definition na ito, itong kj, we can say na yung tawag dito, k2 is also greater than, is less than k1. Okay, less siya kasi, for example, yung e minus v1, compare mo yan sa e minus v2. Dahil mas malaki yung v2 kaysa v1, yung difference between e and v2 ay mas maliit kumpara sa difference between e and v1. So, ang implication is yung k2 is less than k1, or k2 over k1 is less than 1. So in this case, we can see na yung c squared, okay, tignan natin na k2 over k1 is less than 1. So 1 plus a number which is less than 1, at square mo yan, then yung number na yun, i-divide nyo by 4 divided by that number, okay, then it will be greater than 4. So C1 will always be greater than 1. Okay? Which means na yung probability amplitude for finding the particle anywhere in region 2, okay, is greater than yung probability na makita niyo siya sa region 1. Okay, para mas maintindihan natin ito, consider natin yung velocity ng particle sa bawat region. Okay, and sinabi natin from this equation na VI is equal to H bar KI over M. So ibig sabihin nito, yung V2 is also less than V1, or V1 is greater than V2. Now, dahil yung V1 is greater than V2, ibig sabihin it spends less time dun sa region 1 kesa dun sa region 2. So that means na the probability na makita niyo yung particle dun sa region 1 is less. Kasi nga mas mabilis siya nagta-travel sa region 1 kumpara dun sa region 2. Yeah, at least that's what it means classically, but it's not generally the case. Okay. Ngayon, tignan naman natin yung case na kung saan yung M1 is not equal to M2. So, in this case, we still have yung ating boundary conditions. Okay, so, yung boundary conditions natin, okay, yung wave function sa region 1 at x equals x naught is still equal to the wave function sa region 2 at x equals x naught. Now, yung derivative na boundary condition is magkakaroon ka ng mass doon, 1 over m1 dx ddx ng psi1, okay, evaluated at x equals x naught, then 1 over m2 ng ddx psi2 evaluated at x equals x naught. Okay, and again, if x naught is equal to 0, then this gives us a plus b is equal to c plus d pa din. And then ito naman will give us a minus b is equal to, so before it was k2 over k1, right? Pero ngayon meron kayong m1 at saka m2, so this will be m1 over m2. So may m1 over m2 tayo dyan. Okay, times c minus d. Okay, and then alam natin na yung probability na yung particle is traveling from the left, from negative infinity towards the barrier. Okay, so ibig sabihin probability is 1, and then yung probability na may particle na travel from positive infinity towards the barrier is 0. Okay, then this gives us 1 plus b. One plus b is equal to c, and also 1 minus b is equal to m1 over m2 k2 over k1 times c. And solving for yung probability, ang ginawa natin before is in-add natin itong dalawa, di ba? And then makukuha natin yung c. So solving for the probability na mag-propagate siya through the barrier, okay, that will be 4 over 1 plus m1 k2 over m2 k1 squared. And yung probability na ma-reflect siya is 1 minus m1 over m2 k2 over k1 squared all over 1 plus m1 k2 over m2 k1 squared. Okay, yung presence nung m1 over m2 dito gives us a little bit of ang tawag dito, sort of extra dimension, diba? Parang mag-iiba yung results natin ng probabilities as a result of having these ratio ng M1 at saka M2, having these effective masses. Okay, so if we now take a look at yung probability current density, okay, so in-impute natin yung probability current density through this equation. Equals a negative I EH bar over 2M psi star del psi minus psi del psi star. Okay, and if we're just looking at yung tawag dito, wave na propagating sa region 1 towards the barrier, which is an amplitude A, then yung current density of that tawag dito, wave is basically EH bar K1 over M1 and then A squared. Okay, yung reflected naman, which is yung wave function na may B na amplitude. So ito ay incident and then yung reflected is negative EH bar over EH bar K1 M1 B squared. Okay, and then yung transmitted T, ito yung dumaan na through the barrier, EH bar K2 M2 over times C squared. So we define now a reflection coefficient. Okay, to be equal to the ratio of the current densities na reflected at saka na incident, which means this is the ratio of B squared then C squared. So now this gives us, medyo mag-overlap. So reflection coefficient is defined as negative JR over JI is equal to B over A squared is equal to 1 minus M1 K2 over M2 K1 over 1 plus M1 K2 over M2 K1 squared. Okay, na kung saan yung minus sign dito indicates na nag-bounce off siya dun sa barrier and now it's moving towards the negative X direction. Yung transmission coefficient naman is defined as JT, yung current density na transmitted divided by yung incident na current density. So this gives us M1 K2 over M2 K1 tapos C over A squared or 4 K1 K2 over M1 M2. So K1 over M1 plus K2 over M2 K squared. Okay, and you also notice that it's just, so if you write the reflection coefficient as let's say R, okay, and then yung transmission coefficient as T. So yung transmission coefficient, if you'll notice, will just be equal to 1 minus R, so be R minus 1. Ang ibig sabihin yan is yung transmission coefficient plus yung reflection coefficient should be equal to what? Should be the case, diba? Kasi yung total probability nila ay dapat equal sa 1. Okay. Okay. Now, if we, okay, so punta ako sa next page. Okay, if we continue this further, yung transmission ngayon, okay, which we, oops. Oh, okay. Ah, okay, yung transmission, expression for the transmission is 4K1, K2 over M1, M2, all over K1 over M1 plus K2 over M2 quantity squared. Okay, and if we write those specifically, if you write itong tawag dito, denominator in terms of yung velocity, remember that P is equal to H bar, K is equal to MV. So ang K over M is equal to V over H bar. Okay, and so ibig sabihin yung transmission dito, okay, we can write as M1 K2 over M2 K1. Okay, so basically nilabas ko lang ito. Okay, and then 4 over so V1 over H bar. Okay, and we can write it as V2 over V1. Okay, magka-cancel lang yung mga H bars doon. Okay, and then yung M1 K1 naman, okay, is, so actually may H bar ka dito, pero you also have M1 K1 dito, which is H bar. May H bar din dyan, so it will just cancel here. So H, tawag dito, this will be H bar over V. Okay, so ayusin natin. So H bar squared yan. So this will be H bar over V1. Okay, and then meron ka pang H bar squared over, ito naman M2K2 is V2. V2 dito sa ibabaw. Okay, so meron kang V2 over V1. I-cancel yung H bar square dyan. And 4 over 1 plus V2 over V1 squared. Tapain ko yung mga maliliit na ano. Okay. Okay, so if we assume that well, we don't assume, let's try to find kung ano yung tawag dito values, okay, ng energy if the transmission is equal to 1. So this means that 1 is equal to V2 over V1 times 4 over 1 plus V2 over V1 squared. Okay, so you can actually see now when V2 is equal to V1, V2 over V1 is equal to 1, then tawag dito, the velocity of the particle in the two region matches, di ba? And yung transmission is equal to 1. Okay, makikita niyo naman yun kasi this will be equal to 1, this will be equal to 1, so 1 plus 1 is 2, 2 squared, so yung transmission is equal to 1. Okay, so in tawag dito, there's a similar situation or circumstance na kung saan nangyayari ito. And this is in electronics, I mean. In electronics, you have impedance matching. And in quantum physics, this condition is also called impedance matching. Okay, so it's basically the same type of impedance matching. It's electronic impedance matching kasi V2 is nothing but yung velocity ng particle sa region 2, and ganun din yung V1. yung velocity ng particles sa region 1. So if nagmamatch yung kanilang velocities, then yung impedances through nung particles through region 1 and region 2 are yung velocity, sorry, ng region through region 1 and region 2 are equal. So if V2 is over V1 is equal to 1 then, and alam natin ang V2 over V1 is M1 K2 or M2 K1, ba? Basically yan yun. Okay. And yung K2, alam din natin from here, saan natin dinefine yung K? Ito. Okay. Diyan natin dinefine yung K. So 2 MJE minus VJ and then H bar. So anong tawag dito? M1 over M2 times 2 M2 H bar squared E minus V2 over 2 M1 H bar squared E minus V1 square root, or pag sinimplify, this becomes M1 over M2 E minus V2 over E minus V1 and then square root. Okay, so since V2 over V1 is equal to 1, then 1 is equal to M1 over M2 E minus V2 over E minus V1, or M2 over M1 is equal to E minus V2 E minus V1. Okay, so yung relative masses nila ay dapat equal dun sa ratio ng differences ng potential with respect to the energies, to the particle energies. Okay, so anong ibig sabihin nito? Okay, we're actually gonna skip a few slides. Okay, so saan tayo pupunta? So what this means is that, okay, to understand what this means, ang gagawin natin ay mag-consider tayo ng ilang examples. Okay. So let's say we have a potential step na 1 electron volt. So ibig sabihin, we can set V1, for example, equal to 0 electron volts and V2 is equal to 1 electron volt. So that's a 1 electron volt potential step. Okay. Tapos, i-assume natin na yung M2 is equal to M1 over 10. So, M2 is 1/10 of the mass of M1. Okay, so what this tells us is if M2 over M1 is equal to E minus V2 over E minus V1, then okay, 1 M2 over M1 is 1 over 10 is equal to E minus 1 over E, then this gives us equals 10 over 9 or 1.11 electron volts. Okay, so at 1.11 electron volts, yung transmission probability, transmission coefficient is equal to 1 for these given conditions. Okay. Okay. What if we let M2 be equal to half of M1? So, ibig sabihin naman ito ngayon, we have 1/2 is equal to E minus 1 over E, which gives us E is equal to 2, okay, electron volts. Okay, so under this condition, you have unity transmission coefficient at pag yung particle has an energy of 2 electron volts. We can also take a look at yung transmission. Okay, ano yung transmission coefficient? Okay, if we let yung energy ng particle, okay, approach infinity. So let's begin with V2 over V1. If you recall, ang V2 over V1 is given by this, okay, or by this, the M1 over M2, E minus V2 over E minus V1. So M1 over M2, E minus V2 over E minus V1, and then yung square root niyan, tama ba? Okay. Yung square root niyan, and if we let E approach infinity, so we take the limit, we're taking the limit, okay, as E approaches infinity of V2 over V1. So ang gagawin natin is we remove E, factor out E. So from the numerator and from the denominator, so magkakaroon tayo ng M1 over M2, 1 minus V2 over E, and then 1 minus V1 over E. And then take the square root of that. Yung factor out na E, of course, will be cancelled. And then you take the limit as E approaches infinity. And what will end up is this term here, it will be equal to 1. Okay, and we are left with square root ng M1 over M2. Tapos yung transmission probability, okay, which is given by V2 over V1 times 4 over 1 plus 2 over V1 squared. Okay, since V2 over V1 in the limit of E approaching infinity is equal to square root of M1 over M2. Okay, then ano ang mangyayari sa kanya ngayon? Okay, well, magdedepende yan sa ano, no, sa M1 over M2. So for the case na M1 over M2 is equal to 10, then yung transmission as E approaches infinity, okay, will be equal to 0.73, and yung case na kung saan yung M1 over M2 is equal to 2, then yung transmission as E approaches infinity will be equal to 0.97. Okay, so yeah, and let's take a look at that in this figure. Okay, so dito makikita natin yung nangyayari. So let's increase that figure further. Okay, here we see kung anong nangyayari for yung three cases, di ba? M2 over M1 is equal to 10, M2 over M1 is equal to 2, and M2 over M1 is equal to 1. So sinabi natin na pag okay, nilipat ko to dito. So sinabi natin kanina na pag yung M1 over M2 is equal to 10, okay, then yung transmission is 0.73 as it approaches infinity, but it has unity transmission pag yung value niya is 1.11. Okay, so pag M2 over M1 is equal to 10, ito yung graph na yun. Okay, transmission is unity, okay, at energy na 1.11 electron volt. So this corresponds to 1.11 electron volts. Okay. Now, as E approaches infinity, so E approaches infinity, ang value niya is 0.73. So this approaches 0.73. Okay, kasi ito yung 0.8 somewhere here, and then yeah, so nag-approach is 0.73. On the other hand, pag yung M2 over M1 is equal to 2, Then you have a maximum impedance matching at equals 2 electron volts. So this is somewhere here. So maximum siya dyan. And then yung energy approaches 0.97. Okay, hindi na siya ganun ka-obvious dito. But yung energy approaches 0.97 for, anong tawag dito? As E approaches infinity. Yung probability, sorry. Yung transmission probability approaches 0.97 as E approaches infinity. Okay? Yan yung nakikita natin na graph. So, interesting yung nangyayari ito sa M2 over M1. You have a peak and then it goes down. Yung probability may peak, okay, at 1.11 and then probability then starts to decrease and approaches some finite value. Ganon din yung nangyayari actually for M1 over M2, pero hindi lang ganun ka-obvious kasi yung infinite energy limit niya ay may probability na 0.97. Okay, now, okay, so let's also take a look at yung kanilang mga wave functions. Ano bang itsura ng wave functions pag impedance match at kapag hindi impedance match? Okay, so dito yung psi1, okay, corresponds to particles with energy less than V2. Okay, so it is essentially zero yung particle, zero yung probability na makita yung particle in region 2 far away from x equals 0. Okay, and what is happening there? Okay, so ito yung incident mo. Okay, yan yung incident. Okay, and once it reaches the barrier, then nag-ano na siya. Nag-zero out na siya immediately, and then zero na siya as you move away from the barrier. Okay, now yung psi2, okay, corresponds to the tawag dito, particle energy greater than V2. Okay. Anong papansin natin dito sa case na ito? Papansin natin is that yung incident na wave function ay paganyan. Okay, and then as it passes through the channel barrier, biglang mag-increase yung amplitude ng wave function. Okay, and the reason for this is that yung particle velocity nga is lower in region 2 kaysa dun sa region 1. Okay, for E greater than B2. Yun yung nakita natin kanina. Okay, in both these cases, M1 is equal to M2. Or sorry, hindi M1 is equal to M2, kundi hindi impedance match yung walang impedance matching dito. In the case na kung saan meron kang impedance matching, okay, you have psi3. So psi3 also corresponds to the case when E is greater than V2, pero meron kang impedance matching. Okay, V2 over V1 is equal to 1. Okay. Makikita natin na if it is impedance matched, then yung amplitudes are the same, pero yung frequencies, okay, change as soon as it passes through the barrier. Okay. Okay. Now, this is what's happening pagdating sa mga unbound states. And ano ang peculiar dito? Unbound states. So, again, first of all, these are called unbound states, kasi nga, the particle is just propagating, traveling towards a potential barrier. It is not trapped within a barrier, katulad dun sa infinite potential barrier or sa finite potential barrier. Or in other examples, it's an infinite square well or a finite square well. So pag ganun ang case, bound state sila and nag-perform sila ng standing waves. Pag unbound states, ito yung mga states mo, it just meets a potential barrier. Okay, and we can see here na if the energies are less than the potential barrier, okay, you still have transmission through the barrier, which is a quantum mechanical phenomenon, not seen classically. Another effect, okay, na makikita nyo dito, okay, na purely quantum mechanical, is that even if the energy is greater than yung potential barrier, you still have this wave-like behavior, okay, ng particle. So the particle is transmitted. So meron pa rin transmission. Okay. It has tawag dito the same energy, but it doesn't have the same velocity. Okay. And if there's impedance matching, there's also a change in yung frequency, okay, nung wave function. Okay, so all of these effects show yung quantum mechanical na behavior ng particles, okay, which you cannot see classically. Okay, so classically, if the energy is greater than the potential barrier, then it simply passes through, okay, the potential barrier. It has the same tawag dito, wave. It doesn't have any wave-like behavior, so it just behaves as a particle. Okay. Now we go to yung concept ng quantum mechanical tunneling, and to demonstrate yung tunneling effect, okay, we consider a step up potential, okay, which we have here, and then connected to a step down potential, which we have here. So this is no different from yung treatment natin kanina ng step up potential. So we just parang dun sa step up potential, we have a potential which is greater potential in region 2, which is greater than in region 1. Pag sa step down, tulad na nakikita nyo dito, yung potential dun sa outgoing region is less than yung potential dun sa incoming region. Okay, so in this case we have 3 regions. Okay, again, yung A ay yung incident wave propagating towards yung first barrier. Okay, yung B ay yung reflected wave of the first barrier. Yung location ng unang barrier is at x equals 0. Okay, yung C is a wave that's propagating from the barrier at x equals 0. Yung D is a wave that is propagating from the barrier at the second barrier. Okay, reflected off the second barrier at x equals L. And then yung F naman is the wave function, okay, that is propagating away from the second barrier at x equals L. Let's say nasa region 1 tsaka sa region 2, just to simplify things, yung potential is equal to 0. And yung potential sa region 2 is equal to V naught. Okay. In all regions, we can write psi x equal to A. So diba, psi region 1 is A I k1x plus B exponential I k1x, psi 2 of x is equal to C exponential positive I k2x plus D exponential negative I k2x, and psi 3 of x is equal to F exponential I k3x. Okay. And K1 is equal to K3 C in this case, which is just 2m over h bar squared square root. Okay. Now, note yung K2 naman is equal to 2m over h bar squared E minus V2 square root. Pero if you consider yung E minus V2 na less than 0, or E is less than V2, then K2 is imaginary. We can simply rewrite yung ating psi 2 of x na equals sa C exponential kappa x plus D exponential negative kappa of x. Basically, ang kappa dito is just I K2. Okay? So, para hindi na natin maisama yung I. Okay? Yung kappa is defined the same way as when we define kappa dun sa previous na lesson. Okay. Okay, so anong gagawin natin? Anong next step dito? Next step dito is to apply yung boundary conditions. In this case, meron kang dalawang boundary conditions. So, you have a boundary condition at you have a set of boundary conditions at x equals 0. Okay, that's psi 1 at x equals 0 dapat equal sa psi 2 at x equals 0. Similarly, yung psi 2 at x equals L ay dapat equal sa psi 3 at x equals L. And then yung derivatives ng psi 1 at x equals 0 ay equal sa first derivative ng psi 2 at x equals 0. Also, yung derivative with respect to x ng psi 2 at x equals L ay dapat equal sa derivative ng psi 3 at x equals L. Okay, we're going to skip yung details. Okay? Yung first naman is a step up, and natutunan nyo na to just recently, di ba? Of course, hindi natin siniset dito yung D minus C. Okay, hindi natin siniset dito yung D to 0 kasi in this case, meron kang wave function that is propagating towards the first barrier because it is the wave function that is reflected off the second barrier. Pero dito sa third region, wala ka nung wave function, walang wave that is propagating from positive infinity going to the barrier at x equals L. So yung kung may coefficient man dyan, which we may say G, then that will be simply be equal to 0. Okay? So ito yung makukuha natin at x equals 0. And yung makukuha naman natin at x equals L ay C exponential kappa L plus D exponential negative kappa L is equal to F exponential I KL. And C exponential kappa L minus D exponential minus kappa L is equal to I K kappa F exponential I K L. At ito yung makukuha natin dun sa boundary na x equals L. Okay, now, before dun sa single step potential, we considered yung transmission probability as the ratio between yung amplitude ng C at saka A, and then squared. Diba? Now, we're taking a look at yung output, okay, from the last barrier, which is yung amplitude na F. And if we take that ratio of that transmitted wave to the ratio of the amplitude of the transmitted wave to the amplitude of the incident wave. So that's F over A. And we take yung modulus squared, so we have yung transmission probability. So the transmission probability is defined mathematically as F over A squared. So yun yung gusto nating i-derive. Okay, and syempre mag-eliminate tayong coefficients. So, dito pwede natin eliminate yung b by simply adding these two equations. Magka-cancel yung b na yan. We have 2a plus 1 minus I kappa k c plus 1 plus I kappa k d. Okay, and we can also do that here. Okay, if we add that, we cancel these two. Then we have 2c exponential kappa L is equal to 1 plus I k over kappa f exponential I k over L. I k L. Okay, so this I can use dito. So I can relate, I can already relate f to a through this equation. So I need another equation which involves d na dapat related sa f. Okay, and I can do that if I subtract this equation from this equation. Okay, so what I'll have is 2d exponential negative kappa L is equal to 1 minus I k over kappa f exponential I k L. Okay, and now I have d related to f. I can put that here. So this will both have equal dapat ito. This will both have f on the right-hand side, and then the left-hand side is a. So I will end up with 2a is equal to 1 minus I kappa k 1 plus I k kappa f over 2 exponential I k L minus kappa L plus 1 minus I kappa k 1 minus I kappa k kappa okay, f over 2 exponential I k L plus kappa L. Or if we simplify, okay, I'm going to skip some steps. So f over a is equal to 4I k over kappa, and then negative 1 minus I k over kappa squared exponential kappa L plus 1 plus I k over kappa squared exponential minus kappa L exponential I k L. Okay, so gusto natin makuha yung probability, di ba? So we have to do tawag dito. First, we have to take the complex conjugate of f over a and then multiply it by f over a. But kailangan gawin yan kasi may imaginary number ka dito. Okay? May imaginary numbers ka dyan. So we have to do yung complex conjugate first, then multiply it to f over a. Okay, so we are going to skip yung mga steps na nandiyan dyan. I'm going to leave it to you to fill in the steps. And we'll end up with 1 over 1 plus k squared plus kappa squared all over 2k kappa, a hyperbolic sign. Nagawa ko. Kappa of L. Okay, so now, ang tawag dito, syempre ang gusto natin gawin dito is makakuha ng plot ng energy as a function of yung transmission probability. Okay, so energy. Okay, transmission energy as a function, or actually transmission as a function of energy ito. And to do that, okay, ang kailangan nating gawin ngayon ay okay, actually hindi natin gagawin yan at this point. We'll go back to that in the next chapter. Okay, after nung first exam. Okay, ang gagawin natin dito is just take a look at yung wave functions. At kung anong nangyayari as the wave function passes through yung barrier, potential barrier. Okay. And to do that, kailangan natin yung ang tawag dito yung amplitude na C, okay, which you already have from here. Okay, so this amplitude relates C to F. Amplitude na D, but you also need yung amplitude na B, okay, which yung steps ay i-skip na rin natin. Okay, I over 2. At isusulat na lang natin dito I KL times K squared plus kappa squared K kappa sine hyperbolic ng K F. Okay. So we now have B related to F, and then C related to F, and D related to F, plus A related to F. Okay. So all we need to do now is to normalize. Okay. Now, yung problem dito is if we normalize, we'll end up with an integral that is infinite. Okay, so hindi tayo makakita ng value specifically for yung amplitude A that satisfies yung normalization condition. Okay, but instead, ang technique na gagamitin dito is to use tawag dito yung amplitude, yung wave function in terms of the unknown amplitude na A. And then, yung trick is just to set A equal to 1. Okay. And once we do that, okay, we end up with a graph that looks like this. Okay. So yung dash line dito ay nag-indicate nung region 2. Okay. So that's where your barrier is. And dito yung barrier was set at, let me see, 0.9 electron volts. So essentially, parang ganito lang siya kataas. 0.9 electron volts. Somewhere here lang yung barrier. Yeah. So this is the wave function. So this is not energy, so hindi yan yung tamang representation ng barrier. But in any case, yung at least in space, yan yung tamang representation ng barrier. Okay? And ganun din para dito sa pangalawang graph. So anong nangyayari dito? So you have this incident wave function. Okay, and as soon as it passes the barrier, so yung amplitude niya ay bababa. And then it goes down further, and then yung amplitude niya dito, so ay bababa din. Mas lalong bababa. Okay, and of course, you expect na bababa talaga yung amplitude niyan because it needs energy to pass through or to tunnel, okay, through the potential barrier. Okay. So itong phenomenon na ito is unique sa tawag dito sa quantum physics. You don't see this type of behavior in classical physics. For example, magbato ka ng bola through a wall at hindi mo makikita yung bola na yon passing through the wall. Okay, there's no way that ball is going to pass through that the ball is going to pass through the wall. Okay. Classically, kailangan mabutas yung dingding para mag-pass through siya. But here, nothing has to happen to the potential. Okay. It remains as is. But then, yung particle, may probability na makita mo yung particle on the other end as a result of, which is, tawag dito, the effect we call as quantum mechanical na tunneling. Okay, so yung energy dun sa first graph is 0.9. Okay, sorry, yung energy ng particle is 0.9 and yung potential barrier is 1 electron volt with a width na tawag dito na 0.5 nanometers. So this is the wave function, pero yung probability, of course, you get from modulus squared nung wave function na yun. So when you graph yung probability, you'll end up with this graph. So this is the probability na makita mo yung particle at these positions. Ito naman yung probability na makita mo yung particle within the barrier. And here we have the probability na makita mo yung particle after it passes through the barrier. So actually, there's very little probability na makikita mo yung particle through the barrier. But the thing is, as it tunnels, meron pa ring probability dun sa loob ng barrier, okay, na makita mo yung particle. Okay, so we'll investigate this phenomenon further, okay, and then we'll also take a look at kung ano yung transmission probability, okay, nung particle sa ganitong klaseng systems in the next chapter after the first exam. Okay, we're going to use a different method there, and that method involves tawag dito matrix multiplication. So we're going to do a lot of linear algebra and also some degree of coding in order to get yung transmission probabilities. Okay. For now, I would like for you to go back through these equations and derivations. Okay. If you can fill in the steps dun sa derivations, that would be tawag dito some sort of practice para sa inyo. Yung steps na yun ay purely algebraic. So hindi ko na masyadong ginawa. Okay, but for you as practice, mas magandang gawin yun kasi some of the exercises and problems at the end of the chapters will require you to do the same type of mathematics. So before we end this meeting, I would like to show you itong graph na ito, itong figures na ito. So these are actual devices, okay, that were made. Okay, these are transistors. Okay, this type of transistor is a metal oxide semiconductor field electron transistor. So that's yung MOSFET ninyo. And N-type simply means na yung carriers niya, majority carriers ay electrons. Okay, you learn about that in physics 173 in electronic physics. Okay, but ang idea dito is that you have barriers can be created, okay, in the physical world. Here you can see, so figure 3.15a, you can see a barrier that is 313 nanometers. So it's not really a physical barrier in the sense na may harang but it's some sort of tawag dito electrostatic barrier, if you can think of that, di ba? Kasi essentially, di ba, electrostatics naman lahat niyan so an electron is repelled because there's a bunch of electrons within that barrier, di ba? So ganyan siya ginagawa. So it's that gate is made of a different material, okay, compared to yung surrounding material niya. And dun sa letter B, you have it is shown na yung barrier na yun is made of tungsten silicide, okay, and you have polysilicon as yung surrounding na substrate. So dun sa letter C, you have you have tungsten silicide on one side, and then you have polysilicon on the other side. And if you zoom in dito, okay, so if you zoom in dito sa region na ito, yan yung makikita niyo sa letter C. So you have this region na ito na iba yung tawag dito, sort of crystallization. Okay, so and that creates yung barrier. So this is actually an oxide. So this is, I suppose, silicon oxide, and anything that has oxygen in it actually acts as a potential barrier. Okay, so you have a potential barrier which is 1 nanometer in width. Okay, so how do these barriers work? So so you have this is a schematic of a transistor. So a transistor is composed of a gate, a source, and a drain. Okay, so source basically tells us na dun galing yung electrons, and yung drain tells us na dun pupunta yung electrons. And the gate controls how much electrons passes through the from the p-type region to the from the source to the drain. In this case, meron kang silicon dioxide, and that silicon dioxide acts as a barrier. Now, pag naka-switch off yung transistor, meaning yung gate has a voltage of 0, then there's no way for the electrons to pass through from the source towards the drain, because you have this n-type region that is preventing yung electrons to pass through. Okay? Now, what a semiconductor does, a transistor does, is mag-apply ka ng gate voltage dito. Okay, and it sort of pushes tong small region na ito dito. Okay, and pushes in the sense na nag-apply ka ng negative potentials, you have negative tawag dito, you have electrons here that repels yung n-type. N-type means na electrons yung majority carriers na, so that it's repelling, it's pushing the electrons farther. Okay, yung electrons na nandito is being pushed in this direction, okay, away from. So magkakaroon ka ngayon ng maliit na channel, okay, which allows the electrons to pass through, okay, from the source towards the drain, just by applying a gate voltage. So that the amount of gate voltage you apply also controls the amount of current that passes through from the source towards the drain. And that is yun yung basically function ng transistor, and that's what you're going to learn in electronic physics. So this is an application of yung quantum mechanical tunneling, because you have electrons that seemingly passes through yung insulator. Silicon dioxide is an insulator, so it has a very large potential barrier, a relatively very large potential barrier, and as it passes through that potential barrier, it also pushes away yung mga electrons na nandito. Okay, papunta dito. Okay, para magkaroon ng maliit na channel where yung electrons from the source to the drain can travel through. Okay. So yun, I hope you appreciate yung tawag dito yung isang example na ito. Okay, and I hope that you've learned tawag dito, something, okay, out of this session. So I will see you next meeting.